In 2.1b, we're going to be taking a look at like terms because we can only combine like terms. And by combining, we're talking about just adding and subtracting. Take a look here. You all know that 2 dogs plus 3 dogs equals 5 dogs. So keep that in mind as we're looking at the combining like terms. I'm going to point out a few things here. When we are adding dogs to dogs, we end up with dogs. That part doesn't change. And to get that 5, we just take the coefficient, how many we have of each. 2 plus 3 gives us 5. Okay, let's take a look with some variables then. Again, I've got to emphasize, and you see all those stars and it's in red, you can only combine, meaning adding and subtracting, like terms. We've seen something very similar to this before, when you can only add and subtract fractions with common denominators because it's the same idea. In this first case, we've got 2/9 plus 5/9, so you're adding the same kinds of things, and you would end up with 7/9. So there's that principle again. These stay the same. What you're adding, that doesn't change. And to get this number here, you just add 2 plus 5 to get 7. Okay, so examples of like terms. Let's just take a look at some examples. I've got 3 different families of like terms. In the first case, 3, 1.31, negative 2/3, 123. What makes those all alike? Yeah, those are all constant. So that's pretty obvious that those are all going to be like terms. Then in the second case, we have 3x, 1.31x, etc., etc., etc. What makes those like? The numbers are different, the coefficients are different, but what you have in each case, the variable part of your term is exactly the same. So that's what makes those like. Is that work in the third case when we have this family? 3xy squared, etc. We've got 3 of these things plus 1.3 of these same things. So what's like in each case? The variable or the whole variable clump there. One thing I want to point out, because it's a common mistake, students will see something like this, 3x and 3x squared, say, oh, the variable's x, but it's more than just x in this second case. The variable part of this is x squared, so these are not like terms. They have to be, the variable part of your expression has to be exactly the same. Okay, combining like terms, I'm going to go back to the dogs, and you can see 5 dogs plus 2 dogs. We all know that. We would have 7 dogs. So what is 5xy squared plus 2xy squared? This part stays the same. We're going to end up with xy squareds. And how many do we have of them? We have 7. So our answer here is just 7xy squared. What do you think the bottom one is? We have 5 dogs minus 2 dogs. We all know we would have 3 dogs altogether. We look at the next one. Thing that you're thinking about when you're seeing this kind of problem, you need to say, are these variable clumps the same? And I go, yep, they're both xy squared, so we can combine them, and we would end up with 3 of those same things, xy squared. Okay, let's go to some examples. Okay, we've got a big long expression here, and it asks us to combine like terms to simplify. So we want to say that in a simpler way. So what I like to do, since I'm going to take advantage of the colors that we have, I'm going to identify like terms. So the first thing we have is an x squared. Does he have any family up here? You look through here, you go, oh, here's another one, minus x squared. So you just combine those two. What is 2x squared minus how many? 1x squared. We would have 1x squared, and I'm just going to write that as x squared. Then we'll take a look at, here's an x. Do we have any other x's? Yep, there's a x there. 3x minus 4x, we would get minus x. And then finally, let's take a look at our constants. We have a minus 7 and a plus 8. What does that add up to? Plus 1. So there's our colorful answer, and that is obviously much simpler than what we started with. Okay, we're going to be moving fast here. I'm going, oh my goodness. We've got our variables inside parentheses. So we've got to simplify that first. Get those out of the bag. So what do you think we're going to do? Yeah, use that distributive property. So let's multiply 4 times each of those. 4a plus 20b plus, same thing over here, multiply that out, 6a minus 21b. Now that everyone's out of the parentheses, we can start combining. So how many a's do we have altogether? Well, we have 4 and 6 a's, so altogether we have 10 a's. And then we have 20 b's minus 21 b's, so we would have minus 1b, and I'm just going to write that as minus b. Okay, this we're going to slow down on, and this is what the issue is here, is this minus. We're going to be very careful with those minuses. Do you recall that when we have a minus sign, we can change, a minus sign, we can change that to addition by changing the sign of what? By changing the sign of the number that comes after it. So I suggest you always do this, or you're going to get tripped up by those negatives. So now that we've got addition, it's going to be fairly easy just to go, okay, we can get that out of those parentheses because those were cosmetic. There's nothing happening in front here. There's nothing we have to do to that. And then plus, we've got some distribution to do, a negative 2x squared minus 6x. And at this point, you're going to go, okay, pretty easy. We've got x squareds and x squareds. 1x squared minus 2x squareds. We know we're going to have x squareds. What's 1 minus 2? A negative 1, so that I'll just write as negative x squared. And then we have negative 2x minus 6x, which would give us negative 8x. Let's try one more of those to be really careful here. So it's the same problem, but I don't have a coefficient out front. I just have the minus sign. So I'm going to change that minus sign to addition and change the sign of everything that follows it. And what follows it? When that minus sign, that negative sign, is in front of the parentheses, that means that that negative sign applies to everyone. So we would have x squared minus 2x, and then we have to distribute that negative sign, minus x squared minus 3x. The rough patch is over. What do we have left? Ooh, check this out. The x squared, 1x squared minus 1x squared gives us 0x squareds. Negative 2x minus 3x gives us a minus 5x. And let's get even simpler here. That 0x squared, 0 times anything is 0. So we don't have to bother with it, and we can just simplify our answer as negative 5x. Okay, I have a few more minutes, and this is an important point. Students often confuse x plus x and x times x. So we've got the same variable, like terms here. How many do we have? Well, we have one of those plus one of those, so we would end up with 2 of those same things, or 2x. So I'm going to write that again. X plus x is 2x. Contrasted with x times x. So the difference is now we're multiplying. So x times x, as you recall from when we talked about exponents, x squared. Okay, I think we're finished with 2.1b. I will see you in the next video.